Hello friends, this video is brought to you by www.moateaching.com.
Till now, we discussed how to solve a pair of linear equations graphically. The graphical method is not convenient in cases when the point representing the solution of the linear equation has non-integral coordinates. For instance, if the solution is root 3 and 2 root 3, it is difficult to read from the graph. And there is every possibility of making mistakes while reading such coordinates. So we have various algebraic methods to find the solution of a pair of linear equations. Let us start with the substitution method. To understand this method, let us take an example and explain the method. Say we have the two equations, x plus y equal to 14 and x minus y is equal to 4. For the substitution method, we find the value of one variable, say y, in terms of the other variable, that is x, from either equation which is convenient. So we start with first equation and find the value of y in terms of x. From the first equation we get y equal to 14 minus x. Next we substitute this value of y in the second equation and reduce it to an equation in one variable. Let's see how. Now instead of y in the second equation we will write 14 minus x. So our second equation becomes x minus 14 minus x equal to 4. Let us open the bracket. X minus 14 plus x equal to 4. This gives us 2x minus 14 equal to 4. So now we have reached a linear equation in terms of x, and this can be solved to find the value of x. On solving further, we get the value of x equal to 9. Now substitute this value of x in the equation that we have obtained in step 2. We get y equal to 14 minus 9, that is 5. So hence we have substituted the value of one variable in terms of other variable to solve the pair of linear equations, and that is why this method is known as substitution method. And finally we write that x equal to 9 and y equal to 5 is the solution of given pair of linear equations. This particular example had a unique solution, that was x equal to 9, y equal to 5. Let us take up another example to understand what happens if the pair of linear equations has infinitely many solutions or no solution at all. Let us take up another example and solve it by a substitution method to understand what happens if the equations have infinitely many solutions. Let us find the value of x in terms of y from equation 1. We get 2x equal to 9 minus 3y, x equal to 9 minus 3y by 2. Now substitute this value of x in second equation. After substitution, we get, on solving, 2 9s are 18, so 18 minus 6y plus 6y equal to 18. We see here that 6y and 6y get cancelled. We have a statement with no variable, but it is true as 18 is equal to 18 is true. So we conclude that pair of linear equations, that is 1 and 2, has infinitely many solutions. Now suppose the statement we had reached was false. Then if the statement we reach is false, then the pair of linear equations is inconsistent. That means they will not have any solution. Let us read the question. Solve the following pair of equations by substitution method. Let us mark the equations as 1 and 2. Now we can pick either of the equation and write one variable in terms of the other. We can see that it is easy to write from equation 2. So from equation 2 we take x plus 2y equal to 3 gives us x equal to 3 minus 2y. Let us substitute this in equation 1. We get 7 into 3 minus 2y minus 15y equal to 2, which gives us 21 minus 14y minus 15y equal to 2. This gives us minus 29y equal to minus 19. Minus minus cancelled. So we get y equal to 19 by 29. Back substitute this value of y in equation 3 to get the value of x. We get x equal to 3 minus 2 into 19 by 29, which gives us x equal to 49 by 29. Therefore, x equal to 49 by 29 and y equal to 19 by 29 is the solution of the pair of linear equations. Solve the following question using substitution method. Aftab tells his daughter, 7 years ago, I was 7 times as old as you were then. Also, 3 years from now, I shall be 3 times as old as you will be then. Let the present age of Aftab be x and present age of his daughter be y. Then he tells that 7 years ago. That means he is talking about some condition between x minus 7 and y minus 7. So he says 7 years ago I was 7 times as old as you were then. That means x minus 7 is equal to 7 times y minus 7. If we solve this further, we get x minus 7 equal to 7y minus 49 and x minus 7y equal to minus 42. X minus 7y plus 42 equal to 0 is the first equation. Next condition is 3 years from now That would mean there is some condition after 3 years between the age of Aftab and his daughter. After 3 years, Aftab's age will be x plus 3, while his daughter's age will be y plus 3, and the condition is that I shall be 3 times as old as you will be. That means x plus 3 will be equal to 3 times y plus 3. Solve this to get equation 2. We get x minus 3y equal to 6. Now we shall use substitution method to solve equation 1 and 2. Let us solve the two equations by substitution method. From equation 2, we have x equal to 6 plus 3y. Substitute in equation 1. On solving, we get minus 4y plus 48 equal to 0, or we can write 4y equal to 48. Solving further, we get y equal to 48 by 4, that is 12. So the present age of the daughter is 12, and let us back substitute in equation 3 to find the value of x. We get x equal to 6 plus 3 into 12, that is equal to 42. So that means Aftab's age is 42 years and his daughter's age is 12 years. Let us read the question. The cost of 2 pencils and 3 erasers is Rs 9, and the cost of 4 pencils and 6 erasers is Rs 18. Find the cost of each pencil and each eraser. If the cost of each pencil is Rs x and cost of each eraser is Rs y, then the two linear equations are 2x plus 3y equal to 9 and 4x plus 6y equal to 18. And now we have to solve this using substitution method. So from equation 1, we get (2x equal to 9 minus 3y), x equal to 9 minus 3y by 2. Substitute this in equation 2. After substitution, if we solve this further, we get 18 minus 6y plus 6y equal to 18. Y terms gets cancelled and we get 18 equal to 18, which is a true statement, and therefore there are infinitely many solutions to the given equations 1 and 2. Let us read the question. Two rails are represented by the equation x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0. Will the rails cross each other? Now, if we get a unique solution for this pair of linear equations, then the rails will cross each other at that point. If we get infinitely many solutions, then the rails will cross each other many times. But if we don't get any solution, then the rails will not cross each other. So let us start using substitution method to solve these equations. From equation 1, x equal to 4 minus 2y. Substitute 3 in 2, we get, solve this further, we get 8 minus 4y plus 4y minus 12 equal to 0. 4y gets cancelled and we are left with minus 4 equal to 0. Now this statement is false. So therefore the equations do not have a common solution. And so the trains will not cross each other.